In the cold silence between stars, fragments of forgotten worlds drift endlessly. They carry within them the fingerprints of the suns that birthed them. Tiny, frozen testaments to creation itself. Most will wander unseen forever, but every now and then the galaxy surprises us, and one of these drifters wanders too close to the warmth of our own sun. That, they say, is how our story begins. The year was 2024, a year already rich with discoveries, yet no one expected what the Atlas Observatory in Hawaii would detect on an otherwise unremarkable March night. A new light had pierced the edge of their sensors, faint, fast, and moving in a way that simply didn't fit. Orbital calculations came back impossible. This thing wasn't looping around the sun like any ordinary comet. Its path was open, hyperbolic, not a single flyby. In a universe of orbits, it was a straight line of rebellion. They named it 3I Atlas, the third confirmed interstellar object in human history. After Oumuamua in 2017 and Borisov in 2019, it was the third time in recorded science that something from another star had entered our neighborhood. But this one was different from them both. Bigger, brighter, and perhaps stranger. Within months, excitement electrified the astronomical community. We weren't just looking at another rock. We were looking at a traveler formed under a completely alien sun. By the time 3I Atlas approached the inner solar system, telescopes across the planet locked on. Early spectral readings told an unexpected story. While nearly every local comet cries water as it awakens, Atlas exhaled carbon dioxide. Scientists compared notes. The CO2 dominance meant it was sculpted in a region far colder than any part of our sun's nursery. Its home star must have simmered dimmer, its protoplanetary disk richer in frozen gas than liquid water. For the first time, we were watching chemistry from a foreign solar system unfold before our eyes, and still the surprises came. The comet didn't brighten or fade smoothly. It pulsed, tiny fluctuations repeating almost rhythmically, as if the nucleus were beating like a heart. Computers modeled gas jets, solar wind, thermal cracks. Nothing explained the pattern cleanly across online forums. Amateurs jokingly called it the comet that breathes. Officially, agencies insisted the rhythm was natural. Unofficially, they were watching just as nervously as the rest of us. Then came the blackout. October 2025, the period when 3I Atlas blazed brightest, should have filled news feeds with images. Instead, data streams blinked out one by one. NASA cited solar conjunction, the sun's position made pointing risky. ESA echoed the same. To the public, it sounded like routine maintenance. To those staring through private telescopes, it felt like a curtain drop at the moment of climax. Within a week, internet communities built their own conspiracy map, links, screenshots, half-translated reports. Independent astronomer Bill Gray formed a coalition of amateurs around the world. They used backyard telescopes, hacked tracking software, and raw determination, and together, they kept Atlas in sight. The data they shared told a story not of absence, but of persistence. The comet's tail kept shifting, bending like wind over water. It was alive with motion. Coherent, deliberate, unnerving. The more the official channels stayed quiet, the louder curiosity became. Alongside Atlas, another visitor rode the heavens that year. C. 2025 R2 Swan. Its 22,000-year orbit bringing it close again after an absence stretching back to the dawn of civilization. When scientists traced Swan's last appearance, they noticed something uncanny. Its previous pass coincided almost exactly with the era Göbekli Tepe was built, the world's first known temple rising in what is now southeastern Turkey. Among the temple's carvings are cranes, vultures, crescents, the same shapes Swan drew across our modern sky. Coincidence? Perhaps, but coincidences have long memories. For a brief season, two extraordinary beings shared our view. Swan, the memory, and Atlas, the messenger. One representing humanity's ancient wonder, the other, the universe's newest whisper. Together, they turned the sky into a dialogue across 22 millennia. When the blackout lifted, telescopes confirmed that Atlas was already receding, traveling outward at nearly 40 kilometers per second. It would never return. But the data gathered. During its brief encounter, reshaped entire models of planetary formation. Analyses showed dust grains, denser and darker than any comet dust previously. Sampled infrared spectra revealed graphite, pure carbon, rather than silicates. Radiation modeling suggested its nucleus was at least 700 meters wide. From that alone, theorists concluded that the disk which birthed it must have been carbon-rich, possibly around a K-type star. Smaller, older, but stable enough for planets to form. A sun not unlike ours in kindness, yet colder, redder, lonelier. If dust can flee from such a sun and survive a million-light-year journey here, it means the same could happen in the opposite direction. Our own solar fragments may already be adrift in other skies, reflecting our sunlight around alien planets tonight. With discovery comes disagreement. Half the scientific community celebrated a triumph of observation. The other half raised an eyebrow at what wasn't said. Why were certain readings missing? From public databases, why release press statements calling it ordinary when the chemistry screamed otherwise? Theories multiplied. Was Atlas too complex, its spectra too easy to misinterpret? Were authorities protecting fragile reputations? Or were they simply terrified of igniting yet another alien frenzy? Social networks, of course, did what they do best, fanned speculation into wildfire. Within weeks, Atlas signal trended worldwide. People analyzed vibration patterns, converting graphs into sound pulses, claiming hidden messages. Debunkers replied ruthlessly. Between excitement and skepticism, something beautiful unfolded. Millions who had never cared about astronomy suddenly looked up. By late 2025, Atlas was little more than a speck beyond Jupiter. Its brightness dropped below the reach of backyard equipment. But even as it vanished, the questions it raised refused to fade. What if interstellar objects pass through every year, and we simply fail to notice most of them? Could the building blocks of other planetary systems be constantly brushing past our own, each carrying chemistry, isotopes, maybe organics, maybe hints of how common life truly is? In classrooms, students began to ask new questions about cosmic exchange. If our comet fragments leave traces elsewhere, are we the messengers now? Entire research proposals emerged. New sky surveys. Wider, deeper, continuous, future missions like ESA's Comet Interceptor discussed equipping instruments ready to launch and chase the next interstellar visitor on. Demand 3I Atlas started as an object of curiosity. It left as a revolution in how we think about planetary migration. Science will document Atlas as a data point. Composition. Year CO2 rich velocity. 40 km origin na true unknown. But humanity will remember it as a story. A story of how one fragment of another world wandered across the infinity, burned faintly in our sky, and taught us that no star stands alone. Every comet, every grain of dust, is a traveler in a galactic ecosystem, material recycled from one solar nursery to another, linking civilizations that have never met. Perhaps that's the true message hidden in Atlas's tale, that separation, on the grandest scale imaginable, is only temporary. Now, as you watch this image, a fading blue spark against black infinity, remember, it's already gone. By the time its light left the inner solar system, it had traveled too far for us to ever catch it again. But its data, its dust, its mystery, remain here. Our telescopes caught a whisper from another sun. Our minds turned it into meaning. That is what humans do. Soft orchestral music swells, visuals of galaxies overlapping. Narrator, steady, hopeful. Maybe 3I Atlas was never a messenger engineered to speak. Yet in discovering it, we proved that we could listen, that across 100 trillion kilometers, even silence can deliver knowledge, and perhaps one day, another world will look up, see a faint visitor from far away, and measure unfamiliar chemicals in its tail, and realize they're studying a relic of the sun, a small, icy body from a bright yellow star that once hosted a curious species. Until then, keep watching the skies. Because out there, in the cosmic distance, our stories are still trading places, dust for dust, light for light, between the stars.